In our earlier lectures, where we had gone through the propositional logic inference system, we had seen that if we are given some premises and we have to check logical entailment with some conclusion, we can do that using the principle of resolution refutation, and we can say whether there is a logical entailment or not. So we have seen the inference system working, reasoning going on, but the problem with that system is it has been presumed, there is a presumption there, that the logical sentences that are coming either from the knowledge base or from the percepts or from some database, they consist of precise data. And there is no uncertainty at all in them. But real world is not like that. For real world problems, imprecision of data and uncertainty of knowledge are inherently a part of the problem itself, and continuing reasoning in their presence without proper tools that can handle this uncertainty may lead to generating inaccurate inferences. So we need some tool for handling uncertainty in real world. So that is what we feel now. So what is that tool for handling uncertainty? That tool is what you have all learned in your college days and high school days also. Probability. So we will now be introducing probability as a tool for handling uncertainty by intelligent agents. Now, usually there are two views of probability. One is called the frequentist view. What is the frequentist view? The frequentist view is, for example, I ask you what is the probability of a certain event. What is the probability that a certain event occurs? For that, what you do, what the frequentist does is, he conducts many experiments. For example, if I tell you that what is the probability that at the flip of a coin a heads will come, what he will do, he will conduct many experiments, means he will flip a coin many times and continuously record what an outcome is coming. According to the frequentist definition, if you conduct infinitely many experiments, calculate the limiting proportion of the event you are interested in. So you continuously do the flip of coins, record the output, whether it's a heads or a tails, and you continue that experiment many times, maybe 10,000, 20,000, 30,000, 40,000, and going on and on and on. When it's quite a huge number, and there is no definition of what the huge number is, you see in the limit whether the proportion of heads, maybe I am interested in probability of heads coming, whether you see what is the proportion. Proportion is number of heads by total number of tosses. By proportion I mean by this. Calculate this proportion after a huge number of experiments and see whether this proportion is converging to some value as the number of experiments rises. The frequentist would say, in the limiting condition, this number of heads by total number of tosses, this relative proportion for an unbiased coin will converge almost to half. And that is why we are taught in our high schools and college that probability of heads in a unbiased coin is half. Similarly, the probability of tails in an unbiased coin is half. What we actually mean by this is this, that we conduct the experiment many times, almost up to the infinite level, and then in those experiments, while we are recording those outcomes, we calculate the limiting proportion in the limit. Limit means when you are tending to infinity. You cannot do infinite experiments. When you are tending to infinity, what is the relative proportion of the event you are interested in with respect to the total number of experiments that you have done. This is the frequentist view of probability. There is another view. I am just giving you a heads up of, that is called the Bayesian view. The Bayesian view is, as it is very evident from the approach, it's called subjective probability. It is actually having a belief. There are no experiments going on here. Nobody is recording, nobody is doing these relative proportion calculations, because there will be, as you can see, in some situations, some events in your real life also, in which if I tell you, will this event occur? It is impossible for you to conduct experiments and then tell me a result. For example, if I tell you, in this election, will this party win? What will you do? You will do infinite elections, or you will see infinite elections and then tell me the result. According to the frequentist view, we cannot do that. what you can say that my belief is that this time this party will win. So it is a very subjective number, subjective metric attached to an event. So it's called subjective probability, and the approach is you have some prior assumption and then you update the prior assumption according to some observation. So that is what we are doing in our real life also. We have a belief, then we observe an evidence, or then we observe some event, and then we update our belief. For example, I say that party A will be winning this time. This is my prior belief or prior assumption. So I tell you that 0.8 is the probability. Before that, I almost assume that since you are coming from after your BTech, you know that probabilities lie between 0 and 1. So I tell you 1 means high probability, 0 means very low probability, almost none, probability of not happening at all. So if I tell you that my belief is very high about party A winning, that I give it a probability value of 0.7, and then I suddenly observe that the next day or 2 days after there was a procession in the road in which that party's flag was being burned. I suddenly understand that the public sentiment against that party, for that party, is not very good. So I update my belief. I tell you, now my belief that the party A will win has changed to 0.4 from 0.7. So that is the Bayesian view of doing probability. You have some a priori assumption, then you see some observation or you have some evidence, and then you update your belief. So how we update our beliefs, and then the way we have a belief, we update our belief, and then according to the changed belief we do some action, is again the reasoning, and that is what we are now going into understanding. That is called inferential reasoning, or I should say probabilistic reasoning, kind of. So more on this, we are going deeper into this subject to some extent, not possible fully within the limited time constraint, but we are going to catch some glimpse in the next video lectures. Thank you.